Hello everyone, welcome to the channel. In this video, we will be getting started on yet another machine learning project. So here we are on the UCI machine learning repository website. Let's take a look at the datasets that are available. Go to task and let's pick a classification task this time. And let's take a less number of attributes. So we have iris, which is the basic machine learning project. Second is rise, okay. Third is card evaluation. Let's take card evaluation this time. It has 6 attributes. Derived from simple hierarchical decision model, this TP may be used for testing constructive induction and structured discovery methods. Okay, so we have this. We need to do a classification task. There will be categorical attributes, 7 to 8 instances, and 6 attributes. Okay, this is the information. You can read through it. Attribute information. Yeah. So this is the class label that we need to predict. ACC, good and be good. Okay. So here's the features. The 6, 1, 2, 3, 5, 6 are the attributes, and the final one is the class that we need to predict. Evaluation level, unacceptable, acceptable. Okay, and all of them are categorical variables. Okay, and we are also given some baseline model performance. Awesome. So next, we will go ahead and download the dataset. You'll get a zip. Once you extract it, you will see these 3 files. First file, as you can see, contains some info about the dataset, class values, and the attributes. Okay. Next is the data, which ideally should contain the data. Let's take a look at the data then. So if I go here, yes. So the first one is buying, which is V high, I guess very high. Maintenance very high. Doors 2, persons 2. Luggage boot, the size of the luggage boot is small, safety is low, and hence the class becomes unacceptable. So this is the dataset that is given to us. Okay. Next we have names, which should contain info about the dataset. Okay, title, sources, past usage, relevant info paragraph, number of instances 1, 7 to 8, 6 attributes, attribute info. There are no missing values again. Class distribution. Okay, so this time we don't have a distributed class balanced distribution, we have imbalanced distribution. Awesome. So this will be the dataset that we will be using for the classification task. So that's it in the video. We'll get started creating the IPython notebook in the next video. Thank you. Hello everyone, welcome to the channel. In this video, we will be looking in the foremost basics, loading the dataset, going over the first few rows. So let's get started. First, I have added the data file for the car evaluation dataset, which we downloaded from here, the UCI repository. Once done, I'll just add some sections before we get started. First is the, let's name it preparation or prepare problem. Next, let me add the loading libraries. Now we will load pandas as obvious. The other libraries we will be adding as and when needed. Next, we'll add a section for loading the dataset, load dataset. Let us import this data. Okay, let me first make sure. Okay. Now, if you go to TOC, you see appropriate alignment. Okay. Now go to files, right click, copy path, paste. So this is the file path. I'll do pd.read CSV. Now, the read CSV is a method provided by pandas out of the box, and it does this. It reads a comma separated value or comma separated value file into a data frame. There are multiple parameters that you can pass. I'll provide the link in the description so you can check out all the parameters that it does support. Now for our use case, we'll be just passing the path, file path. And if you remember, the data does not have any column names. Hence, we'll do header equals none. Now, I'll just do data.head. And you can see the top 5 columns, the top 5 rows. My bad. Now, if you remember, since you already know the column names, we can pass that column names into our data frame. So this is the page. We have these 3 and 3, 6 attributes and 1 class. So we'll be adding column names, calls equals. I'll copy all of them. Just this. We'll find and pass these columns in the names attribute calls. If I run this, you can see all of the column names are added successfully. Now, this is all what we needed to do in this video. In the next video, we will try to summarize our data. So thanks for joining in. Bye-bye. Hello everyone, welcome to the channel. In this video, we will be taking a brief look on some of the descriptive stats that we can infer out of this data. So first, let's create another section, as always. Summarize data. One more section maybe for descriptive statistics. Okay. The first is the shape method, which is exposed by pandas directly, data.shape. It gives us the dimensions of the data, 1728 instances in 7 features. Now, this is a brief of what the method documentation looks like. It returns a tuple representing the dimensionality of the data frame. Column 1, 2, column 2, 3, 4, 2, 2. So back to this. So next, we will take a look at the types of features that we have in the data. Data.dtypes, and it gives us all our objects. Now, since you've already seen a brief of the data here, we know that all of this data are categorical variables. All the features are categorical. And the documentation looks like this. It is a series of data type of each column. This is sample, float, and data and string, and the same are printed down below. Next, let us try to find out what are the different types, since each column is categorical, which means any column has a fixed set of values that it can take. Now, let us try to use Python and pandas to figure out what those values are. So, for call and columns, again, columns is the names of the features that we have manually typed in. Let's print data call, which gives us the data series, not value counts. It is again a method exposed by pandas, value counts. It gives us count of unique values. So we have a data series which looks like an array, and the value count will give us the count of what we want is the same. Right? If I run it, we'll see v high again. Let me present it properly for which angle. So this is the buying attribute, and it has values v high, high, mid, and low. Similarly for all the other attributes. And we can also infer that all of these attributes, except for the last one, which is a class, has proper or balanced distribution of the values, right? 432, since there are 4 possible values, and 576, since there are 3 possible values. The last attribute feature, which is the class, has imbalanced distribution, the majority being going towards unacceptable cars. So this was a brief of what we could infer from the data using pandas and Python. And these were just 3 of the possible descriptive stats that we could do. We can, of course, do many more. But rather, we will be taking a look at the visualizations part for that. So that's all in this video. Thanks for watching. Bye. Hello everyone, welcome to the channel. In this video, we will be taking a look at the data visualizations for the car evaluation dataset. Now, in the previous video, we have done the preparation and the summarization with descriptive stats. Now we will add on, say, a text, the data visualizations. Now, the first thing that we will visualize is a count plot for all of the attributes, of course, except the class. Now for that we need to import a couple of classes, couple of libraries. First we'll import matplotlib, matplotlib pyplot, that's ELT. Another one we will import is cbond as essence. Once done, we will move to visualization section, and then we will type in figure fig size equals 10, comma. Now this will make sure that the output will be of the size 10, 10 rows 8 columns. Next, for I, call and number 8 calls. Now what I did here is all the columns except the last one, since we don't want to count for the last. Dot 3, 2, minus 1. It creates the number of subplots that, as its name suggests. SNS dot count plot the data, x, which will be the column, since we have subplots, so the number of count plots for each count plot. View, which is class. This should be. Then we'll do plot.show. And okay, it says list indices must be integers. Okay, no need for the comma. Okay, now it says x, so the x is small. Keeping my fingers crossed, yeah, it works. Now this does give us 6 plots which correspond to the 6 features, 6 attributes for the data. But if you look here, the attribute names are being overlapped, right? Not good. So let us add one more plot dot height layout. Awesome. Now these are the count plots, which means for the buying attribute, we don't have any good or very good car evaluation for any cars that are placed in very high or high segment. Same with maintenance, but here we see very good cars are available for high maintenance. That's fine. The safety. So here you see very good cars are highly safe. No questions asked. That's what can we say? So another evaluation or another metric that we can use to do sort of visual data analysis or visualizations is Y data profiling. So let me show you. Okay, so first we need to import it. Let me import it. Install -q for quiet import. We don't want logs because there'll be a bunch of logs. Y data underscore profiling. So while it installs, get to me, and believe me, these are very few logs compared to if you don't put this -q flag. Now we'll do Y data profiling import profile report. We'll run it. So after the first cell executes, the second will execute, and we will be, of course, getting a notification if there is any error. Now once done, we'll move on to our visualization section and do a data dot file report, and the report title, let's say profile report only, and the progress bar equals false. Of course, it's up to you. I'll provide you the top link in the description. You can take a look and tinker around with the multiple parameters that it offers. In short, this Y data profiling is a single command line execution which will let us know how our data, basically do a EDA on the data. So over here it says alerts, which is all of our 6 attributes are uniformly distributed, which again, if we go to our previous descriptive stats analysis, we'll see that this is 432, all of the attributes are perfectly balanced. And the same is represented here, uniformly distributed. Now if you go to overview, you'll see the number of variables, observations, which are instances, or the rows. Missing cells, we don't have any missing cells. We don't have any duplicate rows. Okay. Size in memory and average record size in memory. Going further down, it will give us distinct, which basically means the number of values that this variable or this column supports or has seen in the training data. Very high, high, medium, and low. 4 distinct values. Distinct percentage, which basically is 0.2 out of 17 to 8 instances. Maintenance, doors, persons, luggage boot, safety, class. So now, correlation. So this is a heat map for all of our categorical variables, how correlated they are. And going by the graph, you can see the safety class and the person's class are correlated. Maintenance and buying is also correlated. And then comes doors, which is slightly less correlated after luggage boot. This is a graphical representation. If you move over to table, it will show us a numerical representation for the correlation. Then we have missing values. You already saw that we don't have any missing values. And this is a sample first 10 rows and last 10 rows. Of course, there are multiple parameters via which you can tinker around with how you want to see this profiling report. So that's a brief for what we had in this video. In the next video, we will go over evaluation or evaluating some of the metrics. And before that, we also need to perform transformations, which is basically converting these categorical variables to a numerical representation so that our model can identify them. So we'll take a look at that in the next video. Thanks for watching. Have a great day. Bye-bye. Hello everyone, welcome to the channel. In this video, we'll be going over some of the pre-processing steps that are needed for any dataset that contains categorical variables, categorical columns. So without further ado, let's get started. Now, let's move over to adding a new section. Let's add one by the name of preparing data. Prepare data. Next, we only want to pre-process the data that we are passing to the model, or the data that we use to train the model. Hence, we will divide the data into x and y. So data.ilog, all of the rows and all the columns except the last. Y would be data.ilog, all the rows and only the last one. That should give us x and y. Now here we'll be using an encoder. First, let's go ahead and import the encoder from sklearn dot pre-processing import audio encoder. Once done, let's come back to prepare data. Encoder equals audio encoder. X equals encoder.fit underscore transform. Yes. Now, audio encoder will basically transform the column, any category column. Let's say column is buying, right? That will transform this V high. So the buying column contains 4 columns, right? V high, high, mid, and low. Now we convert all these values to 0 from 0 to index minus 1. So 0, 1, 2, and low will be transformed to 3. So it's simple categorical encoder, audio encoder, and the encoder fit underscore transform, it will fit or train on that x and then transform the values of the x. It will return a data set, which will again be return a numpy array, which will be stored in x. So that will work. Now, this is all that we wanted to cover in the video. In the next video, we will be evaluating algorithms and we'll start off with training the data across multiple models. So thanks for watching. Have a great day. Bye-bye. Hello everyone, welcome to our channel. In this video, we will start off with evaluating the algorithms and look forward to training the data on multiple machine learning models. So without further ado, let's get started. First, we'll add a section, not here, my bad. Wait, this here. Only this section, okay. Let's go to prepare data, add a section here, evaluate algorithms, add another section, train data. But first off, we will have to split our data, the train test split. So let us go ahead and import it from sklearn. sklearn dot model selection, import train test split. And for the train data, we have train test split We'll have x train, x test, y train, y test. We'll pass in x, y. We'll also pass in the test size 0.2, which basically means how much of the data do we want in the test set. And then finally stratify, which basically means since we already saw that our y column or the feature column is imbalanced, we want to completely emulate the same ratio in our test and train set, split it. Hence we'll use train test split. And okay, now we'll be using multiple models, right? So let's start off adding them in the libraries first. We'll be using, let's say, from sklearn.linear model, import logistic regression. Yes, from sklearn.neighbors, let us import k-neighbors classifier. From sklearn.tree, import decision tree classifier. From sklearn.svm, import svc. So we copy all of them, so we don't need to type again. Go to train data, add up them in the models. Let me show you how. So we'll have a tuple which will have a name for this. Let us say logistic regression LR, and the object for the logistic regression. Similarly, we have force. One would be KNN, another one would be decision tree, and the final would be SVC. Let's update the names as well: KNN, PT, and SV. Okay. Now, once we have added the models, let us look through the models, name and model in models. We'll fit all of them in our training set. Once we have fed it, we'll find the score. So model.score of our train and x and y, and then we'll print out the score dot format, the name of the model and the score. If we run this, it'll take some time since we are running 4 models. So you see, the logistic regression is giving us 69% accuracy, KNN 93%, decision tree 100%, and SVM again 95.8%. So going by these metrics or results, we'll be continuing forward with DT. So in the next video, we will use the decision tree classifier and run it on our test data. So that's it in this video. Thanks for watching. Bye. Hello everyone, welcome to the channel. In this video, we will be using the model that we trained to test the remaining part of the data. So let's go to the train data, add a section, let's name it test data. Next, we need to import of libraries. Let's import a data. We will be using the decision tree classifier. Now model.fit, train the classifier on the training data. We'll score using model.score, x test and y test, and then print the score. That should be it. 97.6% accuracy on the test data. Now let's load one more method from sklearn, which is sklearn.metrics, import classification report. Let's go to test data. Now here we need print classification report y test, and the other parameter is the predictions. So predictions equals model.predict x test, and feeding it predictions and see. So the classification report will give us a report for all of the 4 classes, their precision, recall, reference, score, and support, along with the macro average and weight average. So this was all that we need to do. One thing to note is the score method would return by default the R2 score, R squared score. So if we want to update, there are links in the description which will point you to the docs. So feel free to explore. But this is it for the video. In the next video, we'll take a look on how to finalize the model by saving the model and loading the same. Thanks for watching. Bye-bye. Hello everyone, welcome to the channel. In this video, we will be wrapping up the video series with finalizing the model, saving the model, and retrieving the model. So let's go to the adding a section. I'll add Finalize Model. Good enough. Add the model name that you want to save it with. Let's say car, pickle. Since we will be using pickle, let's import it. Import pickle. Done. It's going to finalize, then the pickle.dump, the model name, and let's go model name and right access. And now we'll be loading it. So loaded model equals pickle.load. Open the model name and read access. And let's find the result of the loaded model. Model.score test y test x test, and then print the score result. So load it. Pickle.load takes one argument. Yes, so here is the issue. It's a 97.68, which is the same as this one. Awesome. So with this, we have come to an end for this project. Hope to see you soon in another machine learning project. Thanks for watching. Have a great day. Bye-bye.